Previously we looked briefly at lighting up LEDs and we had a very simple circuit. Today we're going to look at how we can do more complex sequences with LEDs. We could have 5 LEDs and it's not much more complex as a circuit. I often get the wrong resistors because I'm absolutely useless with math. Fortunately, there is a resource at digikey.com or digikey.ca that allows you to find the correct resistor in your collection. For these LEDs, we've been looking for 220 ohm resistors, and there's a couple of different types. There's the 4-band type, which you'll recognize as having red and brown and gold. And there's the blue type, which have got 5 bands, and as you can see, you can select here which resistor you're looking at and find the value of it. So there is a way of working it out in your head or from a table. I'm not that good, so I like to use a tool like this. In Tinkercad, you can actually select the type of resistor that you want. So we can give it a name and tell it what resistance we want in ohms or kilo ohms or k ohms. Our circuit has ground connected to ground on the board, and then each LED connects its small pin, its cathode, to the ground rail, which is connected all the way across horizontally. And then for the anode, for the power long leg of the LED, we connect to different pins on the digital side. But if you look carefully, you'll see that we've chosen the ones that have little tildes, little squiggles next to them. And that is because these have PWM output, pulse width modulation, and that's going to be important when we want to set the brightness of the LED. So let's take a look at some code and how we can utilize this. And before we do, let's just start the simulation to show all 5 light up and go off. So that's an extension of the code we had before. You'll notice that I've done some examples here to go through. And the first one we have here simply has 5 LEDs. And so I've got a multi-line comment at the top, 5 LEDs all at once. And we define them as 11, 10, 9, 6, and 5. Those are the pins that I mentioned earlier with the tildes, the pulse width modulation ones. These are the pins that people describe as analog out. Now, it's not really analog out, but it gives the effect of being able to go from 0 to full on in graduated segments. It allows you to vary the output up and down smoothly rather than it being on or off. It's not binary on and off. You can set how much current you want to send through. For now, we're just going to turn them on and off. So we set the LED names, LED 1 through 5, to the pins, and then in the setup we set them all to output. And just for completeness, we do have the serial begin again, but we don't really get much value out of it at the moment. We'll come back to that in a later lesson. And then we set all the LEDs on, 1 through 5. We wait a second, and then we go back to having them switched off. Easy peasy. Now, If we have red and blue LEDs, we can do a little police circuit. We can use the same layout, the same pin layout, we can use the same circuit, except this time we can actually use the different varying brightnesses using AnalogWrite. So you remember we use those PWM pins. Instead of using digital write, if we use AnalogWrite, we can actually send a signal that's between 0 and 255, 255 being full on, 0 being full off. And so we can have a nice effect where we alternate between the red and the blue side. Now, yeah, police cars probably don't have 3 LEDs on one side and 2 on the other, but you know, for a demonstration it shows what we can do. And so in the serial, I just say which LEDs are on and which are off, so that you can actually see in the serial monitor which is supposed to be switching on and which is off. Now here I've got 50, 100 and 255, which makes the middle LED brighter, the middle red LED brighter when it's actually switched on, and when they're switched off I make the left blue LED brighter. Don't really have to do that, but it demonstrates that you can set the brightness. So if you've been finding the LEDs too bright for you, this is the way you can reduce the brightness. And here we have the analog effect with the middle being the most bright, so it just shows that you can actually have each LED have its own brightness and then all of them switched off at the same time. A fun thing to do with the analog is RGB. So these are special LEDs that have 3 power legs and then a common ground. Now sometimes they're the other way around and it's a common anode, but the one that I've got, the one that I got in the official kit, has common ground, common cathode. And I forgot to change the description up here, so I change it to RGB LED just for completeness. And we only need 3 pins here. Instead of R, G and B, they're in the order R, B and G on my LED. So I've got pin 10, 6 and 9. I've only got 3 legs to talk to. And then we can say all of them are output. And then I have a little sequence here that sets each leg's value and brightness, and as you can see, combinations give different colors. So if you only turn one leg on, you get red, you get green and you get blue, but if you have all of them on at once, then you get essentially white. So if I had 255, 255, 255, it would be white, but by varying the different values you get different colors. So have a play with that. If you've got an RGB LED, have a play and see what colors you can create and what effects you can create. I'm setting them with a 1 second delay at the start, and then I have a very swift delay later, and then it loops round and it keeps going. Obviously, being a Doctor Who fan, I can't avoid doing the Tardis effect when I have the ability to fade an LED in and out. I have just one LED on pin 9 and I set it to output. But here is something we have not seen before. It's a special loop called a for loop. And what it allows us to do is increment or decrement. So it means we can go through this loop and add 1 to the value each time we go through the loop until it gets to 255. So it says set brightness as a start to 0. Each time you loop, each time check it's less than or equal to 255, which is full on. If it's not 255, then add 1 to the brightness. So brightness plus plus is the same as saying brightness is brightness, add 1. Check it hasn't got to 255. If it hasn't got to 255, add 1. And then each time it goes to the loop, it does an analog write. So it says send to LED, which we saw is LED pin 9, whatever the brightness is. So it'll go from 0 to 255 and have a very tiny delay. Then we wait a second. After we've done that loop, we go backwards. We say the brightness starts at 255, goes down to 0, and we take 1 away each time. Brightness minus minus means brightness is brightness. Brightness is brightness minus 1. And then it keeps going around the loop until it gets to 0. So it'll keep looping until it's more than or equal to 0. It'll wait a second, and then it goes to the main loop, the Arduino loop, and starts all over again. It sets the brightness to 0. But this is a different brightness to this because it's calculated here, and it does it again. The final demonstration is the Larson effect, named after Glenn A. Larson, who was behind Knight Rider, Battlestar Galactica and other 80s shows, and all the nerd fans that have come afterwards. Again, we're using the same circuit, 5 LEDs, and we set them all to output. But here we have quite a long sequence. It's not the most elegant way of doing it, but it works, where each LED in turn is set to a varying level of brightness so that the LEDs look like they're chasing right and left with a nice little fade effect. So just in the comments I've got where the brightest part will be so that you can see what the sequence does. So it starts with low across the board with just half brightness, first LED, and then the bright part moves to the right, gets to the end, it dims again, and then it goes all the way to the left, and then it goes back again.